2, 3, 4. And the way you join them is you can either you put nails or bolts. So where the green line represent, okay, these are the fasteners. Okay, fasteners. Okay, so it can be nailed also. So fastener can be nailed. It can be glued. Yes or no? Right. So sometimes you can glue them. So over here you can glue them. You can glue them. You can glue them. Okay. So this is glue. Okay. So if we were to look into the nail, okay, if we were to look into the nail, right? So basically for this section, this is the structure we're going to analyze. Okay, that is a cross-sectional view, and always remember this. Okay, failure will occur at the what? At the joints. Okay, failure will occur at the joints. You all agree or disagree with that statement?
Agree.
Right, you agree to the statement, right? If you are going against someone twice your size, okay, twice your muscle, where will you hit this person? At the joints, yes or no? You don't go for his chest, okay? He's not going to feel anything. You don't go for his head. Maybe head is okay, but you go for the what? You go for the joints. That's why if you look at any martial art, anything, right? It's not about how much strength you have. It's more on the what? The technique. Ip Man. Unbelievable. Okay, so you go for the joints, okay, or the place of the weakest part. That's where it hurts most, and that's where failure will occur. Likewise, right? We go for the what? We go for the joints. Now, so we are going to calculate the shear, the stress or strength of the joint. Okay. Now, this is I did a lot of consulting work with this knowledge over here for landscaping companies that are building large decks or decks that are a certain height that they need calculation. I do a lot of this type of calculation. Okay. So the calculation is for what? Right now, how many of you build your own decks? Right. So you some of you do build your own decks. The thing is, can anyone tell me what is the spacing that you use for two fasteners? Anyone? What's the rule of thumb? Anyone? It got quiet out there. No one building decks nowadays or what? 6 feet? 8 feet? Okay. So the spacing is all dependent on the load. Okay. So when I calculate structures that have very heavy loading, this spacing does decrease. Now, question for you guys. Does the length of the nail, okay, does the longer the length, okay, of the nail improve the quality of the joints? Anyone? Okay, I ask this. Changwu Park is safe, 6 to be safe. Yeah. If you don't calculate, you put 6. If you do calculate, you might go up to 10. So now the thing is this. Like, does the length, there's a critical length, okay? Does it mean that the longer, the better? Anyone? No. You're absolutely right. No, it does not matter. Okay, but as I said before, I did this calculation. I thought it will, but no, it will not. Okay, later on when we go to the theory of this aspect of longitudinal shear, then you understand why up to a critical length, any length that is longer. Okay, so length means what? The length of the nail. So this is the length of the nail, for example, length of nail. Okay, after you reach a critical length, the longer you go does not matter at all. Okay, Okay, but you have to hit a critical length. Okay, too short, it will matter. Okay, you will hit a critical length. Okay, anyway, let's come back to here. Okay, let's come back to here. So we are going to calculate we're going to calculate the stress or the strength of the joints. And the formula that we're going to use the shear flow. Okay. So we're going to, some of you might ask me why shear flow, but hold to your horses first, okay? So we're going to use the shear flow first for this work. So the shear flow is Q, small q, right, is equal to VQ over I. We have seen this before, okay? All of you have seen this expression before, okay? All of you have seen before. So if we look at the units, right? So V is in Newton, Q is in meter cube, I is in meter to the power 4. The unit is in Newton per meter. Okay. So we can relate, okay, we can relate the shear flow relate to the shear flow to the spacing to the spacing and resistance force of the nail. For this case, we are looking at nail, okay, of the nail. So the formula, this is a big lengthy. So the formula, okay, is Q is equal to resistance force of the nail divide by what? Divide by spacing of adjacent nail. Okay, so the unit is again force is Newton, spacing is divided by what? Meter. So this is the only new formula that you see. Okay, so we can equate both of them because the units are the what? Are the same. Okay, and then sometimes we are going to use, we might even use shear stress is equal to VQ over IT sometimes for the analysis. Okay, so beside this, what is new? Nothing. We are still going to apply, remember this rule? We are still going to apply this same rule. Okay, it's such a beauty, you know, the same rule that we have created. I do apologize. It's messy. I'm going to stick it here. Come on, you cheeky sort. Right. So the same rules, you still apply the exact same rules, right? You still apply the rules that I've written down here. So I'm going to stick down here. Okay. So you still apply the same rules. Okay. The rules did not change at all. That's the beauty. So that's why mathematicians are very miserable. Okay. They have to derive an expression that represents anything and everything, then they're satisfied. All these are derived from what? Mathematical expression. Rule 1, rule 2, rule 3, what? Rule 4. And you can apply it to everything. Later on, when we do thin wall, same rules. Nothing changed, man. Okay. Now, let's look at another example. Okay, so as I said, the only thing that is new is this. Okay, this is the only thing that is new. The rest, same, no difference. And I'm going to, so another thing that I'm going to show you later on is I'm going to teach you how to sketch the distribution of the shear flow. Okay, now, and now we're going to look at, so if you were to download, okay, on Avenue to Learn, I have all these images for all of you. Okay, so these are the example. Okay, so we're going to do this question. Okay, so this is the example that we're going to do. Right, so we have a double web grider is constructed from 2 plywood sheet. They are screwed to wood members at its top and bottom. The allowed bending stress for the wood is 8 kilo KSI, okay, kilopounds per square inch, and the allowable shearing stress is 3 kilopascal, not pascal, pounds per square inch. If the fasteners are spaced at 6 inch apart, okay, and can support 600 pounds in the single shear, determine the maximum load that can be applied to the beam. Okay, so this is a typical question. So if we look at the cross section, right? So everything is made from wood. Okay. So this is our double web. Right, one on the left, one on the right, and we have top and bottom. They are all made of wood. And then if you look at this structure, okay, it's not easy to construct a structure like this because every time there's a spacing, you have to drill a through hole from one end to the other end, and you can put in a fastener. So this is just an example. Okay, you won't do this in industry. You just put nail on one side and nail on the other side, or screw one side, screw on the other. But this is how the way they're going to fasten it. So this is the structure that has been given. Okay, so let's look at the information that we have. So some of you might say, what are we looking at? Okay, so this is a bit confusing. So this is our transformation, right? This is X, Y, and this is our rotation Z. This view over here, the cross-section view over here, right? So this is our Y, this is our Z, this is our rotation about X. So you can call it, it's from the front view or it's from the end view. Okay, either one. Okay, either one. You are fine. Okay, so we got that. So now, so what has been given to us is the normal stress. Now I want you to ignore the normal stress because I've not taught you bending yet. So wait, let's look at the mode of failure. Okay, so there are going to be 3 possible mode of failure. Okay, so we can only calculate 2 for now because the third mode of failure I can only teach you after term test 1. Okay, so we're only going to calculate what? 2 modes of failure. So first, so mode number 1 is the failure of the joints, right? And failure of the joints, the formula that we're going to apply is Q is equal to VQ over I. And this can be equal to resistance force resistance force of the